working as a team. It allows with that functionality of giving you a seamless and complete track record of changes. It allows you also to go back to earlier states of metadata. You can detect conflicts early in the development process, so before deploying changes to production. It allows executing control and QA on work submitted by team members, either manually by so-called code reviews on pull requests. So whenever a team member submits changes to Git, that typically triggers a workflow of manual review by peers. However, it also opens up possibilities for a lot of automation. So when you maintain your source on Git, you can plug in automated code quality checks. For example, there's a very popular open source library called PMD with very good Apex rule sets, but even beyond Apex. So you could, for example, ensure that, let's say, custom fields that are contributed to your source, you can set quality rules like they should have descriptions or help texts and so on. So endless opportunities for automation, be it security scanning, be it enforcing quality rules and so on when you transfer from working basically in a black box sandbox to moving all your changes through Git. Right. I would say let's jump right into it. So I'm just giving you an overview of the 8 steps I want to address today. So setting up a local environment is the first one, but I will basically handle that very quickly. We will then bootstrap an SFDX project. We will then fetch existing metadata from a production org. Then we create and initialize a Git repository and push our metadata that we have fetched there. Then we will perform a simple change in a sandbox to that org and see how it goes through Git, basically submitting our changes and then integrating them by merging a pull request. And then we might, if time allows, even show a very simple continuous integration that gets triggered from basically submitting a change. Right, no time to lose. So let's start with setting up local environment. I won't demo this step. Obviously, I have my setup on my machine. Just touching very briefly on the essential tools. So typically you would have Visual Studio Code. There are other IDEs like WebStorm, which some Salesforce developers use, but Visual Studio Code is free. It's very popular. There is a very good extension pack maintained by Salesforce, which is also for free. So it's a very typically setup to have Visual Studio with this extension pack. Then you would have to have Node.js installed and the Salesforce CLI, sometimes referred to as SFDX or SFDX command line tool, and you need Git on your machine. That said, it doesn't mean that every contributor in a team to a Git-based workflow would need all that tooling. I will also show how DevOps tools, either Salesforce DevOps Center, which is a free, recently released tool by Salesforce, or tool like our own Hute, or there are the wide landscape of Salesforce DevOps tool, how they support Git-based development without basically going through the command line and so on. But I think for the benefit of understanding, I would like to really show how it works from the command line. That would be a typical setup. There is a good trailhead on how to set up this tooling to get started, basically for Git-based development from your machine. So let's skip that and go into the next step. Assuming we have these tools installed, we can very easily create a Salesforce DX project on our machine. So let me do that. I have here Visual Studio Code. I will just run the shortcut that opens different commands, Command-Shift-P, and there we have SFDX create project suggested. which will ask me, there are different templates available. I will just go for standard. I'll give it a name. I'll call it with June 23. And that it will ask me where to store that. So I have a directory called stores where I store different projects. So yeah, that's it. We have a local SFDX project now. It follows the typical structure of SFDX projects, storing metadata in a directory called Force App. You can see here the typical, probably familiar structure of metadata. Yeah, and so as a next step, let me go back to my browser. With this project created, we can now connect a Salesforce org. I will use a production enterprise edition, or actually it's a trial org I'm using, but it's like a production org. I'll connect there, and I will then show you 2 commands to basically fetch existing metadata from that org. So let me first show you how to connect to an org. It's the command authorize an org. It will ask me, is it a production org or a sandbox? In this case, it's a production org. We give it an alias because it creates a permanent connection to access it then under this shortcut. I call it ACME because it's kind of made up org for a non-existing company that we refer to as ACME. So yeah, I have already entered my credential here. So I'm just basically logging in, and that will make this command successful. So now I basically, under the alias of ACME, I can now access this org permanently. So there are different commands, for example, SFDX open default org. So my default org is now that ACME org, and I can basically easily open it now from the CLI without going through authentication, which is very practical. All right, so let's look into the next step. There are 2 commands to run. Actually, I can't copy paste from here. So let me just, either type them. So I will run that command now. It's SFDX project generate manifest -t package from org, and then we use our own alias ACME. And I will share, or we will provide the slides that have this command from where you can copy them. So this is creating a so-called manifest, which basically lists all the metadata in the org. And that's already created. So you see we have now a package XML, which is kind of a list of all the metadata file. Obviously, this is not all things that we have already created in the org. The org is pretty, it has only little configuration, but it basically has all the metadata that comes with a Salesforce org of that edition. So, and the next command I'm going to start is force source retrieve -x package XML. So we are referring this file now and say, give the command to please retrieve all that metadata to our local file structure. So I'm again referencing our alias ACME org, and will run the command, and that will take a bit of time. It could, in a large org with a lot of configuration, it would probably take longer, so definitely several minutes to probably half an hour, but it's a one-time step. So what we are attempting to do here is get the existing metadata, then put it under version control, and then as we build out the org, we would always only see the changes that we do towards that Git repository. So while it is running, and it will take a bit of time, let's already look into the next step. So we need a Git repository. There are many ways to host Git, even free of charge. There are many Git platforms, like GitHub being the most popular or probably renowned one, but there are Atlassian Bitbucket, there is GitLab, there is Microsoft Azure. So many vendors offer Git hosting service. Most of them also have very good free offerings, and you typically only need to go on a commercial plan when you are a larger team or when you want to have enterprise security or so. But it's very easy to get a free Git host. You could just register on GitHub. Yeah, then you would basically create a repository there. That's 2 clicks, but I've done that in our, so we have a so-called organization there. When you sign up, it's called Hute Demos. And there I've just created a blank repository. I named it WIT for today's event, June 23. So it's completely empty. And in the next step, we will now basically commit, so ship the local metadata that we have fetched from our Salesforce or into that repository. And the commands, I've listed them here. So there are a couple of steps. We first need to create a local Git repository. We then say add all the local files in that directory. Then we make a so-called commit. Then we connect our, in this case, GitHub repository, because Git always consists of a local repository or typically and a so-called remote where you can then share your work with your collaborators, and we will then push the source there. So let's see if fetching the metadata has completed. It looks so. So if we now look into our Force app directory, we will see that, yeah, a lot of metadata has populated. So first we see a lot more directories than earlier. Earlier, when we looked, we just had a blank structure of a couple of directories of typical metadata. Now we have the actual metadata of that org on our local machine. So let's go ahead with the command I've mentioned. So first git init, this creates a local repository. And Visual Studio Code will immediately highlight all files because it tells us, hey, you have local changes. They are not basically committed yet. They are not stored in your repository. So that's what we do next. We say git add dot, which means add everything from that directory to Git. And then we will make a so-called, or it's not adding yet to Git, it's the so-called stage. So you stage your changes, and now we say git commit -m, m for message, and we will just provide an information what we are doing here. And I would call it initial metadata fetched from our org. This is what we want to now add to our repository. Then we want to connect our remote repository. So remember the one, this here, that is still empty, that we have created on GitHub. So I'm copying this URL here. And then I will type my command. So it's again a one-time step. I say git remote at origin. And oh, the copy paste didn't work. That's interesting. So sorry for that. We want to copy the remote repository. So let me again bring up the URL. Sorry for that. It was the demos. And there we have our repository called with June 23. So I'm copying here this URL, pasting it here. Now it works. And so we have now connected our repository, and now we can push our source. So we say git push -u origin main. And that will now ship the metadata that we fetched from a Salesforce org to that Git repository. So if we now refresh here, in a second, we should see that this repository has now populated with all the metadata. Let me check. Not yet. It should, once we refresh. Let me check, did I? Okay, it's still, sorry, the push command is still running. It hasn't completed. There are a lot of files to send to Git, so it will take a bit of time. Again, it's a one-time step. So we only once in the life cycle of this Salesforce org, we would fetch all metadata and then push all the metadata, these thousands of files that we have retrieved to Git. Once this is completed, you will always only work on basically the so-called diff, the changes that reside from your work. So it's a bit uncommonly long, but let's give it a bit more time to push our changes. And let's look ahead on what's coming next. So yeah, next step would be to actually perform work in our Salesforce demo org here. So yeah, we have basically two options. We can work with sandboxes, developer sandboxes, or scratch orgs, which are both source tracked, which means Salesforce internal mechanism supporting, basically showing us the changes so that we can only retrieve changes and work efficiently, Git-based. Scratch orgs are temporary orgs that you typically only use for a single feature. I will not use them today because there are additional setup steps. We would have to do some cleanups in our metadata so that we could easily push it to a completely empty scratch org, because scratch orgs come up without metadata. So I'll be using developer sandboxes for my demo. And yeah, I have created one. Let's see if it came up. So this again is my org I'm using today. So let me just see if the sandbox that I have created for this demo has already completed. It's still in creation. So we will use one existing one, which is totally fine. I was a bit late in creating it. And yes, as you know, probably creating dev sandboxes can take a while. Yeah, let's check back if the push has committed, and it hasn't, which is a bit strange. So let me cancel the command and try it again, because yeah, now we see the counter. Okay, so it was somehow stuck. Yeah, let's go one step back, see our repository. So if I refresh it now on GitHub, you see it has the metadata of our org. So again, here, all the metadata file. So it's now a kind of a copy of my local directory. We see the history. So we have only one so-called commit. This is what I've done a couple of minutes ago. So it has my comment, what I did. So initial metadata fetched from org. And from now on, various or a team of developers could basically create their local repositories, the local clones of this repository, could do changes there and then ship them to that common repository, which is this collaboration that Git supports. And we would consider this as our source of truth from now on, instead using a shared org or so as a source of truth. So now, yeah, let's, in a next step, let's perform a simple change in a sandbox. And I will do that using our own, here you see this is the sandbox I was creating. It's still in creation, but yeah, as I said, I have others. So I'm using our own tool, Hutte, now for basically facilitating it, but you could do it completely without tooling. You can do it from your VS Code. You could authorize your sandbox, open it, do changes, and then pull the changes with commands. But yeah, there are visual tools. So there is Salesforce DevOps Center, there is our own tool Hutte, there are other tools that you can use to somehow facilitate that. So let me show how it works here. Very briefly, I'm starting a so-called feature. I'm calling it, I'm giving it a name. It's very common to name your features according to many teams have an issue tracking system like Jira, let's say, and there you have these references. So it's very common to reference your issues, basically using that reference that allows them for all kind of automation. And now let's do a very simple task. So I would just say add a custom field comment on account, just for the sake of for the demo. I'm choosing a very simple use case. And sorry, it looks like I've picked an old sandbox, which is not a source track. I'll not go into details here. So that's a small flaw in my demo. So let me, to pick another one. Oh, it looks like the org I've created for today just became available. So let's try with this. No, it's not yet ready. So let me try once more. Let's see. I'm sorry for that. Let me see if the org opens. It's still in creation. So let me add a different sandbox. And now, yeah, let's use this existing sandbox. Sorry for that quick flaw. So it's a sandbox against the production or trial org we are seeing here. And yeah, let me now again start this new feature. We call it add a custom field comment on account in this dev HM org. We have now created a feature, and I'm now logging in and will now perform that very simple change. So let me go to accounts, or let me do it from the setup directly and from the object manager. So I'm going to account and I'm adding a new field, calling it, yeah, let's use a text field and let's call it comment, and let's give it 255 fields, and then we can basically choose which profiles we add it to, and we will put it on the account page layout and save it. And now if we now go back and click the changes tab, now this is the magic, let's say, of Salesforce source tracking. And as I said, you wouldn't need a tool for that. You could use the command line to run an SFTX command asking which files have changed since my last commit. And it would give you the same output. But here we have it very nicely visually presented. And so you as a contributor to your project working on this work item here, you'll now see, okay, your changes basically on this feature have the following impact on your org. So a new custom field metadata has been created, the admin profile has been changed, the account layout has been changed, and apparently also a report type has been changed. And now you can basically pull your changes. And what that will do is it will create a so-called pull request. So it will bring these changes that you have done in your sandbox to the shared Git repository. So we can now decide, let's say we include the actual new field, and let's say we want to add it to the layout, but let's say we as a team have decided to manage permissions differently. So there are, of course, different strategies on how to manage profiles. We know it's always a complicated topic to get profile changes integrated, because you have a single file across potentially many features that will touch on that file. So just for the sake of simplicity, I skipped that topic of managing profiles. We will just decide now to ship our new field and the change to the page layout to our Git repository. So I will give it a message, and it's good practice to have like a reference, assuming I have a issue tracking system, and there I have an issue that is called HUT1. I would use that reference. I explain what I'm doing here, and then let me submit it. And now what this tool is doing, it's the same that you could do from your local machine, but it's of course very convenient to not have to have your local setup and have to run commands, but just use a visual tool. So it will now for us basically do a similar operation that I've shown before. It will fetch metadata, however, only the few files I've selected from that Salesforce org, and will ship them to Git. So we will soon basically see the metadata changes or additions. So we have done one change to the page layout and one addition of a new metadata file. We will soon see that come up on Git. So let me again, I've unintentionally closed the window. So let me again open up GitHub, and we used the demos, and there we use this one. So let's let's now see. We go back here. Okay, the pull is still running, so the time can vary, like with every Salesforce interaction. Sometimes things take a bit longer, but it should be basically a quick interaction to fetch these changes now, since we have just touched upon 2 files. So let's assume this will finish very soon. And what we will then see is a pull request created, and that gives the person who is basically in charge of integrating and the development lifecycle, then typically would be notified, or the peers. There are different ways to set up your code reviews, would be notified that there are new changes available for review, could review them, and we could already, just from the fact that a pull request was opened, we could run all kind of automation, like the quality checks that I've mentioned in my intro. So let's check in again. Okay, we see now pull changes successfully. It lists again which files we have decided, which we have basically touched, and which we have decided to pull. So not all the 4 files that we modified, but just the 2 that we decided for, and it links us the pull request. So we can go directly here. And so we can see what the changes are. Okay, we see on the account layout, there is a change. So these 4 lines have basically been added, meaning this comment field that we have introduced was added to the account layout, and the complete new metadata, the account fields, shows up as a new file. So we see here green as a new file, and this is a file with changes. And yeah, let's say I'm now the release manager. I could decide, yes, I want to accept this change, and I could perform a merge, which is meaning integrating that change into our source of truth. And that would typically go hand in hand with automation for deployment. And that is now the last chapter that I would like to talk you through before going into the Q&A. So yeah, we have now seen submit your changes. I've done changes in the sandbox. I have submitted them. I've done my pull request. And now we are here integrating and promoting changes. So we have seen pull request is basically open. That means people, depending on your setup, get notified, they do the review, and they ultimately perform the merge. But before I do that, I want to open the complex topic of continuous integration and continuous delivery in all brief. So all Git platforms, I've mentioned a couple, GitHub, GitLab, support some kind of automation, so they function as CI/CD platforms, and so you will be able to do to instruct what the platform should execute for you when certain action happens. And the typical action is a pull request gets opened or a pull request gets merged. These are key actions. So typically a pull request opens, you would run, let's say, quality checks, because then you could, as a reviewer, when you come in and you need to basically see what the changes are that are contributed, you might already from an automation have an automated review, which tells you, okay, the change seems good. Or it might tell you, so if we would have, let's say, an automation that would enforce field help texts, we would have already a warning saying, pay attention, the developer missed to add a field help text. So yeah, great power for automation here. But yeah, in this case, we don't have any automation in place. So it's up for the manual reviewer, and we will skip this this step now. It would take too much time to show you how to set up, let's say, such a quality enforcing continuous integration. But what I want to show you is when we merge that pull request, we would like to deploy that change to a next stage. And this I would still attempt to show you very briefly. So we maintain a public repository called the recipes, and there we show some of these very typical Salesforce integration tasks. And we have here a recipe or template called CI/CD incremental deployment. And this shows how on GitHub you could automate basically that when a pull request gets merged, the content of this pull request, so in this case our two files, this new field metadata and the account page layout, would get shipped to a destination org that is to be defined. Typically it would be UAT or QA, so you would likely not directly deploy your changes from Git into production. In a very simple setup you could even do that. But yeah, typically the automation would then, once the reviewer has decided that the changes are good, merges them, would basically ship those changes to the next stage. So yeah, I'm just giving you a very quick intro how this looks. So these automations are typically in a format called YAML. So it's a pretty readable format where you can basically define what the automation should do. So you specify basically what triggers this action. So in this case, we would want to run it when a pull request gets merged, and then you have your actual action that is performed. And yeah, with this recipe, basically we have done the work for you. This is very universal, so it has nothing to do with the product footer. So it's a very universal way on how you could basically take the delta, the diff of a specific pull request, and promote it, deploy it to the next stage. So again, it's a one-time setup. We could now take these YAML files, put them to our own repository, and from then on, they would create so-called GitHub actions that then run on the specified command. So let's briefly do that. We would follow the steps here in this recipe, which explains us exactly what to do. It tells us create basically 3 GitHub workflows. So we are copying the first one. And here it says created under a directory GitHub workflows incremental deploy. So we will add that to our project. So it lives in the same project where our metadata lives. We want to now create a new directory, new folder called GitHub. There we create a new folder called workflows, and in that directory we create a new file called incremental deploy.yaml, and we paste the content here. And then we want two more files. We want a so-called PR YAML. That is what we will now skip. That is what would run when we open a new pull request, but let's add it as well. So we create a file called PR YAML, and we copy from here the content. And then we create a third one called main YAML. 5 minutes to go. I hope I will make it. New file, it's main YAML. And again, we copy and paste the main YAML. So now we have to commit those files. So we again do git add. And again, that's a very admin or DevOps task that would only be once performed. It shouldn't scare you by your application lifecycle manager or so. And will then basically control for all the pull requests for the entire lifecycle of your org, basically facilitate this automation. So let's just say git commit -m, add a simple diff deploy pipeline. Pipeline is, yeah, a different term. And let's git push. And we have now shipped that change. So in this case, just for the sake of speed, normally you would all perform all changes through a pull request, sending it to a reviewer. But since I'm now showcasing this as a single project, I have just directly committed these changes. So I didn't go through a pull request. So now we have these files added. And yeah, GitHub basically following this convention .github, it knows now what to do with these files, and it knows that when we open a new pull request or we merge one, it will execute these files. Just a side step, we also maintain similar recipes for other platforms. So if you are using GitLab or Azure or Bitbucket, you can also look into our recipes. I'll have the link in my slides. And yeah, they follow a slightly different syntax, but basically do the very same things. So yeah, we have now added our automation. There is one step missing, since we want to instruct our our automation to deploy changes. Of course, we need to somehow authorize GitHub to basically deploy to an org. And I don't have a UAT org in this setup. I will just, for the sake of demoing, I will set up directly the production org as our target org to basically deploy to. So let's again see in the recipe, it tells us now how to do that. I will run this code here to get basically an authentication token of our production org. So let me just say this, and again I'm using ACME, which is our org that we use here. And then what it says next, copy the value of sfdx out URL to the clipboard. I'm doing that here. And then we need to create a so-called environment variables. It tells us how to do that. We go to settings, secrets and variables, actions. So settings, let me follow it. Settings, secrets and variables, actions. So here it says secret and variables, actions. And it tells us new repository secrets, new repository secret. This is the value, and we want to save it under this name here. And we have a secret now. We have added our automation. So now, if I didn't do any mistake, if I now merge the pull request, that means, integrating this change into the source, what should happen is actually these two files should get deployed to the org, which we have specified, in this case, our production org, and we should see runs completed with no job. Okay, we should then see the output here. And yeah, looks like I have a small flaw. Let me just check again, and sorry for that. So I'm seeing our repository. I'm seeing now we have merged. It looks like the automation is still running. Yeah, it looks good. So we see here, we see here that now our automation that we have specified from our recipe is run. We can follow it here. So it first, and let's have a look back into our recipe. It first has to install certain tooling, because you can imagine it as GitHub now spinning up a image, a machine, a blank machine for us, with an operating system. It will then have to install SFTX. It needs, of course, all the tooling. So it takes a bit to do that. And once done, it will run these commands, which basically take the content of the pull request and ship it to the org that we have specified, in our case, production. So I think we can move to the QA. That was surprisingly fast. So actually it has already ran, it successfully deployed. So we can even see here the output, and it looks very good. So if I open the production org now, we should have a new Command C field on account, and should see it on the account page layout. So this is the dev sandbox, where we obviously have it because we have added it. But let me now also open our production org. Just say open default org, which will spin it up. And let's go to setup, and let's go to account. Object manager, and to account. And we should see a field comment here. So we have basically succeeded now doing an end-to-end life cycle. Just to recap, first we fetched all metadata from our production org into Git. We created a repo, all the one-time steps. We have shipped all the existing metadata to our GitHub repository, which we have created. Then we have created, or in this case, I used an existing developer sandbox. We have done a change there. We have selected which of the changes we performed we actually want to move ahead. We did a pull request from those, and then we have set up an automation, also a one-time step. Then the reviewer came in, he accepted the change, this new field, and the change to the page layout. And our automation basically promoted the changes, deployed them to the next stage. In our simplified setup, we use directly deploy to production, but typically you would go through several stages, what you then typically call a pipeline. Yeah, that was certainly a lot of information. Sorry for rushing you through, but yeah, you will have the ability to basically follow the steps. I've outlined them in the slides, which I'll share with you. And I've also done with a colleague from our team an article with a video on Salesforce ban on a very similar content. So there you can follow a similar demo in a video that done by one of my colleagues. Yeah, you can also reach out to me if you have any questions on Git-based development. And I'd like to open for questions. Thank you very much.
Thank you. And we have few questions for you.
Sure.
First of all, that you get lots of compliments in the comment. This is really a good one.
Thank you very much.
It's make a life easy for so many people. Yes, it's so the first question is person Rai, and he was asking about is like do we have an auto merge facility when the approver approves the changes?
Yes, that is possible. Again, that would be a configuration on GitHub. You can actually, I use GitHub most, I know it best, but I'm pretty certain that every Git hosting platform has such a feature. I don't have an open pull request now, but we might see it on the, yeah, this one is already merged. But indeed, there is a checkbox called auto merge, and you can configure it in a way that you could say, I need at least 2 reviewers, and then it's green. Or you could say, I need 2 reviewers and my automation needs to finish with a clean result. So we have said there could be like automation enforcing the quality. So you could run quality rules, and that would be like an automated review. And you could specify an auto merge in a way that you say, okay, auto merge when all criteria is met, or when 2 out of 3 are met or so. And yeah, indeed, that is possible and very practical, because it then, yeah, it takes away another manual step of performing the merge.
Okay, so we have this another question from the same person, that for revert changes, how we will do that. So basically, like, do we have some facility for the revert changes, and how we can do that?
Yes, so you can, our simple CI here can even deal with destructive metadata changes. So we could now purely from Git roll back. I mean, that is a Git, you can with a pretty simple Git command, you could say roll back a certain commit or roll back the latest commit and so on. Of course, in practice, it's more complex than that. Because yeah, if imagine the org has moved ahead or the same metadata has been touched by other users, then you cannot easily in every situation roll back. So I mentioned in the benefits of Git that you can roll back to any state. That is true. So you can easily get back to an earlier state of your metadata. But to be very transparent and open, in practice, there are some pitfalls to do that. So it's not that Git is just by using Git, you have a full-blown revert capability to any earlier state of your org. Theoretically, you can do that. And if you, let's say, work with Scratch org, you could indeed go back to any commit. So years back state of your org, you might basically check that state out and then deploy it. But as we know that Salesforce also, the environments change with the seasonal releases and so on, there are, of course, many pitfalls. And in practice, rolling back changes requires a bit more. Our very basic CI. So for this example here, it would work. I could roll it back. We would then automatically, again, once we merge the rollback, which deletes this field and removes it from the page layout, these basically 2 changes would get deployed and reverted in production. But in a very simplified setup, in a happy path, this would be easy. But just a word of caution, in reality, rollbacks are complex. There are a third-party DevOps solution which are specifically specialized in facilitating rollbacks. Or imagine you ship changes that have data dependency, configuration data. So in reality, of course, there are many complex situations. So take it with a word of caution, but theoretically, from pure metadata perspective, you are able to step back to an earlier state. You can always ship your diff, including the destructive metadata, meaning deleting files. But it's more complicated in practice.
And
Right. So, Harald, can I just put it?
yeah,
So,
yeah.
if we use the newly created fields in our any Apex method, and then we are just reverting the changes, so is it possible? Like we had already used that in one of our Apex method or any of the automation process. So,
Exactly, that is of course one of these complex scenarios. I mean, you would probably have in your deployment automation. Let me briefly think it through. So let's say you go back to an earlier state of the repository where the field did not exist, and then also, of course, the dependent apex did not exist, right? Because Git always has like as we have it as source of truth, assuming all developers follow this process, then every state is valid and deployable. So even if you roll back to an earlier state, you don't have a real conflict, because at that time the classes didn't exist and the field did not exist. So if you really want to revert to that change, you would have to basically do the destructive metadata on the class, on the fields, and so on. I can't promise that our simple recipe would handle a complex scenario. We really see our recipes as a help to get started. But yeah, it basically has supports destructive changes. So I could imagine that even if we would now deploy a class that references our new command fields, a trigger, let's say, and then we say, no, okay, we want to revert back to, and we always have the complete commit history. So we want to get back to exactly this state here. Then we could do that, and it should theoretically work. I hope this
thank you,
answers.
man. And it's a game-changing session. So, thank you.
So if you have time, we can take more questions.
Yes, I'm happy to go. I do have actually an obligation afterwards, but I'm happy to go 5 minutes over time, and we still have 4 minutes left. So we would have nine minutes in total, and I'm happy to take more questions, of
Anybody
course.
willing to ask any question? If anybody has any question, you can unmute yourself and then ask. I receive a question here from Deepak. Is can we compare Salesforce DevOps via Git and Copado?
Yes, it's a good question. So of course, I mean, again, a word of caution. So I'm not speaking here as a vendor, but as a member of the community. But as you see, I've used our own tool, Hute. So we are also a DevOps vendor. In some way, we are a competitor to Copado, but having quite a different angle. Yeah, take my answer with that, basically taking this into account. The way I would see it is, Copado also uses Git under the hood. But it is an all-in-all, very enterprise, very complex deployment solution that has its own workflows built around. So if you onboard Copado, you kind of adopt the Copado way to deploy and to make your pipelines and so on. And it hides away a bit your Git. So it brings you its own way of working, again, with the benefits of version control and so on. Our approach is slightly different. We are really relying on the power of Git. So some things that you would find in Copado directly, I'm not an expert for Copado, but I would assume you would probably handle your review process directly in Copado. And our philosophy is at Hute is rather we basically interface to Git, to the Git host of your choice, and then certain steps like the code review and even this automation that I've shown you, you would just do them on your Git host, which is very well capable of running this kind of automation, where Copado has built these things into their own product and give you like a complete solution, whereas we provide solutions for isolated challenges in a Git-based development, but leaving a lot of flexibility to teams and independence, basically, because all the automation I've added, it has not really anything to do with our product. So we kind of share our knowledge, our know-how by making these recipes openly available, but anyone can use them regardless if their team uses the command line and VS Code or uses a visual tool. So that would be my summary of comparing to Copado. It's probably also worth talking briefly about DevOps Center, because it's exciting that Salesforce has released an own tool doing, again, something similar. I would say DevOps Center is a bit more similar to what we as Tute does. So it provides a UI to those things. It allows teams to contribute to the Git-based development without doing all the complex stuff I showed you, like installing locally on their machines VS Code and running commands and so on. So for no-code developers, it also provides like a visual tooling and interfaces with your own Git host. Yeah, so I would say Tute compares quite well to DevOps Center. So DevOps Center is, I would, from my personal view, the disadvantage of DevOps Center is it's pretty early stage, and it's a free tool maintained by Salesforce, which is great because it's much better conceptually than ChangeSet. But yeah, I think as we can just move faster. For example, DevOps Center currently only integrates with GitHub and not with others. So if you are, let's say, having your source on Bitbucket, you would not be able yet to use DevOps Center. So DevOps Center will also evolve. It's a young product, but yeah, we have a different approach to UX and design and making it very usable. But I would say from the philosophy, the DevOps Center and Tute following a different, a similar approach. And then there are tools like Copado or Flossum, which are more targeting a very complete, very kind of own way of managing your complete Salesforce DevOps, whereas our tool and DevOps Center I see more a bit as toolboxes and kind of central tools where you can have your cockpit for your whole process, but less, let's say, opinionated, less forcing you into a very specific way, and yeah, leaving you a lot of individual freedom to design your workflows and grow them over time, add more automation and so on. I hope this answered the question. Yeah, I hope you understand that it's a bit